This is 2-6, proving statements about angles, part 2. Last time we left, we were talking about linear pair and vertical angles. I want to briefly review that. Linear pair, when you have two lines that intersect, for example, like we have here, they'll have a vertex at this particular point. Angles 1 and 3 form a vertical angle, and vertical angles are congruent. So if the measure of angle 1 is equal to 17 degrees, that means that the measure of angle 3 is also equal to 17 degrees. You need to go back to your chapter 1 notes and review about vertical angles and the rules. Remember quickly, the rule for vertical angles is the two angles, angle 1 and angle 3, must, rule 1, they must share the same vertex, which is here. Number 2, if this line here is being used for angle 3, it must also be used for angle 1. So if they share the same vertex 1, then this line, if I extend it out, is it being touched by angle 3? Well, it is. It's right here. But if I go on the opposite side of the vertex, it better be used for the angle that we're saying it's vertical to, which is angle 1. But when I go the opposite direction here, it is being used also by angle 1. Number 3, so number 1, they must share the same vertex. Number 2, both of the lines must be used by both of the angles. So here's our first line. It is used in touching angle 3 right there, and if I go the opposite direction, it's also being used by angle 1. Number 3, finally, the second line must also be used by both the angles. So here we have this angle, this line here. Okay, if I go from the vertex and downward, is it touching angle 3? And it is. Well, if I go the opposite direction with this same line, it better also touch angle 1. So when I shoot up, does it? Yes. Therefore, angles 1 and 3 are vertical angles. I can look and do the same thing with angles 2 and 4. So if the measure of angle 2, 17 away from that is going to be 63 degrees if this is 17. Okay, so this means that this will be 163 degrees, and angle 4 is also vertical to angle 2, so therefore it is also 163 degrees. 3 rules. Number 1, they must share the same vertex, which they do. We see it there. It must also, the two lines that make the vertical angle must touch both. So here it is. If I go to the left, it better touch angle 2. It does, right here. But if I go the opposite direction downward, it better also touch angle 4. And it does, right here. Number 3 is the second line here. It better touch angles 2 and 4. When I go this direction, does it touch angle 2? It does. If I go in the opposite direction, does it touch angle 4? It does. Therefore, making 2 and 4 vertical angles, which are congruent. Finally, or next, I should say, excuse me. If I look here at these two angles here, where are the angles that are vertical? Angle 1 is congruent to angle 4. These two form a vertical angle. How do I know? They share the same vertex. And here's the two lines. Here's the first line. It better touch angle 1, and it does. And it better touch angle 4. It does there. Let's look at the other line that is supposed to connect with the two. Here's the other line. It touches at the vertex. This line better touch angle 1. If I shoot up, it does. And it better go down and touch angle 4. It does. So therefore, 1 and 4 are vertical angles. Let's look at some other angles on this diagram. A lot of people are saying angles 2 and 5 are vertical angles. Well, are angles 2 and 5 congruent? Let's look. They share the same vertex. That's a check. That's good. Number 2, remember, it's 3 rules. Number 2, the line must be, they touch both of them. Well, here's the first line. Does it touch angle 2 and 5? Yes, it touches angle 2 right there, and it touches angle 5 here. Well, what about the second line? Here's my second line here. Okay, it better touch angle 5, and it does. Does it touch angle 2? No, it touches angle 3. Therefore, angles 2 and 5 are not vertical angles. All right, let's proceed forward. Some other information. If I write or say that angle C is congruent to angle F, it does not mean the same thing as the measure of angle C is equal to the measure of angle F. The congruent symbol here means that angle C is the same size and same shape as angle F. However, when I write the italics M as in the measure of angle C, the measure with the equal sign, both these two together, and I'll use a different color here, the measure and the equal sign together, this now says or means I want the actual degree measure. So if the measure of angle C is 25 degrees, I want you to write the number, the numerical value of 25 degrees. And because I wrote the measure of angle F, I want the numerical value there as well. So when I write the measure and an equal sign, you use the numerical values. When I have no M and the congruent symbol, that now means that you're just saying they're the same size and shape. Okay, we talked about that with segments. Go back to 2.5 and review that quickly. Let's look at some proofs. Right, we need to review the steps for a proof. Let's suppose I have here, example 1, we're given here this information here, and this is from your book, example 1. Okay, so please refer to your textbook, example 1 from chapter 2-6, and here's what I want us to look at. We have 3 angles, and we need to draw 3 congruent angles. So I'll take my protractor out and draw them the same measure. But in this case, we're given this information, and I'm thinking proof. Now step 1, what's first thing we do? We write what's given. Okay, what's given is the measure of angle A is congruent to the measure of angle B. We're also given that angle B is congruent to angle C. And then also in part 1, when we write the given, we must also draw the diagram, which is drawn for us. Angle A is congruent to angle B is congruent to angle C. Okay? Now, that's step 1. Step 2, I need to think about what do I need to prove. I need to prove that angle A is congruent also to angle C. That's step 2. I write down what I need to prove. Step 3, I say, what postulates, definitions, proofs, anything I can think of that will prove that A is congruent to C. Well, I go back to the given and look at the diagram. A is the same measure as B, B is the C, and now we're asked to prove that A and C are congruent. And I say to myself, oh my goodness, wow, just throwing out an idea, I think I can prove that by the transitive property of equality. And so I write that down because I'm thinking that's the best way to prove that. So now I begin my 2-column proof. Remember, you can write this in paragraph form. Here it is. My statements on the left, the reasons on the right. Here's the first thing. I have the angle A is congruent to angle B. Angle B is congruent to angle C. Both of those 2 things were given. So again, usually the given is number 1. Number 2, here I have here, I say, now I write, now the next thing I'm writing is, the measure of angle A is equal to the measure of angle B. I'm taking away the congruence and putting equal. So I'm transforming from congruent to equal. We did that with segments. How do I go from congruent to equal? I'll put the measure sign in here. That's because of the definition of congruent angles. If they are congruent, then they will also be equal. So I'm going from congruent to equal in this next statement. I also wrote in here that the measure of angle B is equal to the measure of angle C, which was given up here as B is congruent to C. So now I'm saying the measure of angle B is equal to the measure of angle C. How do I go from congruent to equal? Same thing. Definition of congruent angles. Remember, sometimes you will repeat your reasons. That's okay. And remember also in proofs, some people may write things, proofs a little differently. As long as you prove it, you're fine. Okay, so I went from congruent to equal on there. That's fine. That's definition of congruent. So far, I said A is equal to B, B is equal to C. Now what I'm going to say is the measure of angle A is equal to the measure of angle C by transitive property. Because the first is equal to the second, And then I say in here, the second is equal to the third. And now I'm saying that the first is equal to the third, which is transitive property of equality. Now look what I probably can do here, because I need to prove that they're congruent. I just proved they're equal. Now I'm going to prove they're congruent. And I prove they're congruent by saying angle A is congruent to angle C by definitions of congruent angle. I went from equal to congruent, and we should know we can go back and forth between congruence and equal. Okay, and we've just proved that angle A is congruent to angle C. I use transitive property of equality. Okay, let's try another proof. Example number 2. Okay, we're going to use the transitive property on this one. And this again, example 2 is in your book. And here we have what went away here? Okay. All right. Using transitive property on this particular example, we have here, we're given, remember our 3 steps of writing proof, write what's given and draw the diagram in step 1. Step 2, write with a proof, write what we need to prove. And step 3, you're going to write down what information you know to prove it. So here we are. Given the measure of angle 3, this angle here is equal to 40 degrees. Also given the angle of angle 1 is congruent to angle 2, so these 2 angles are congruent. Angle 2 is also congruent to 3. And I'm asked to prove that this angle here is also 40 degrees. So that's what I need to prove. Well, it says 1 is congruent to 2, then 2 is congruent to 3. I'm already thinking that sounds like transitive. Okay, transitive property of equality. But I'm jumping ahead. So step 1, we've written the given. The diagram was drawn. And then I've also marked up the diagram because that helps me. Step 2, what am I asked to prove? Prove that the measure of angle 1 is 40 degrees, which I've done here, or which I've written already on the diagram. And now we do step 3. In step 3, I think about what can I use to prove that. And to me, it sounded like transitive property of equality. Why? Because 1 is equal to 2, 2 is equal to 3, and now they're asking us to prove that basically 1 and 3 are equal to one another. They just put actual values of 40 degrees in there. Now, here I am. First statement, the measure of angle 3 is 40 degrees. Angle 1 is equal to angle 2. And then angle 2 is equal to, is congruent, excuse me. Angle 2 is congruent to angle 3. That information, all of it was given. Well, what can I say in my statement? Start thinking, what do I know? I can say angle 1 is congruent to angle 3 because of transitive property. Bam, it's not much to write on that one. Now I'm going to go and say, the measure of angle 1 is equal to the measure of angle 3. I go from congruent to equal by definition of congruent angles. Okay? From congruent to equal. And then finally, now I can say the measure of angle 1 is equal to 40 because now I'm substituting. I know the value of angle 3 is 40. I just proved or shown that these two are equal. And I also know that 40 degrees and the measure of angle 3 are the same. So I'm going to use this by substitution property of equality. All right? And we will pick up part 3 on your next lesson.